two consecutive integers such that the difference of their squares is 19. Okay, so let's see if we can solve this one. First of all, consecutive integers. If one is x, if I let the first number be equal to x, what would be the number next to that? Anyone? Roberto, what would be the next one? No? Anyone else wants to try that? No? That would be, it won't be double. Okay, let's take a look at consecutive integers. Like we're talking about 1, 2, 3, 4, and so on. These are consecutive integers, one after another. Okay, Roberto, you said 20x, that's not correct. Sashini said x1, no. Renee said minus x, no. If the first number here is x, what would be the number right after that? What's the difference between one number to another? Okay, Renee says x plus 1. Okay, if you guys agree with Renee, put the check mark next to your name. X plus 1, she said. Okay, so Shin, you agree with that? How about Roberto? Do you agree that the next number would be x plus 1? We can check it. We say x, if x equal to 1, 1 plus 1, that would be the next number. Actually, at least the next number checks out. Okay, how about the rest of you? Minita, are you agreeing with us? If the first number is x, if they're consecutive integers, the number after that would be x plus 1. If the first one is x, okay, good. So how about Roberto? Can you tell me what would be the number after that if I wanted to know in terms of x? That would be x plus what? Because sometimes in our word problems, we need to have more assumptions. Excellent, Roberto. That's x plus 2. Very good. So when you're talking about the consecutive integers, please make a note of that. You're going to see something like that on the next exam and also final. You need to know that. Daisy, I see you just walked in. Can you put the check mark next to your name if you can hear me? So if you're talking about the consecutive integers, if the first number is x, the next number after that would be x plus 1, and the next number after that would be x plus 2, and x plus 3, and so on. Okay, now we will establish that. Now, here it says if two consecutive integers, we have two consecutive integers. So we look at x and x plus 1 only right now. These are the two consecutive integers that we're looking at. The difference of their squares is equal to 19. So if the first integer is x, the next integer is x plus 1. Now they're talking about the difference of their squares. Well, let's take a look at the squares. If the first one is x, its square would be x to the power of 2 then, right? If the next one is x plus 1, their squares would be x plus 1 square. Does that make sense? So their squares look like this. Can I see a check mark next to everyone's name if you can follow up to this point? You're talking about two consecutive integers. One would be x, the other one would be x plus 1. Their squares would be x squared. The next one would be x plus 1 squared. Very good. So everybody follow that. Now they're talking about their difference, the difference between these two. So when it's a difference, we have to take the larger number, which is, this is a larger number, and then that would be the smaller number. And their difference would be, we're going to subtract them. We already squared them, we subtract them, and should be equal to 19. So let me write down the equation first of all, so we can follow that. So our equation would be x plus 1 squared minus x squared is equal to 19. Now, we already set up the equation to solve for x. Let me see if everybody can follow up till this point. Can you put a check mark next to your name according to what this is? Find two consecutive integers such that the difference of their square is 19. So that's how you set them up. The difference of their square is equal to 19. Okay, Daisy, do you follow that so far? How to set up the equation? Okay, I want everybody to write this down on a piece of paper, and we're going to discuss this on the day of the next on-campus exam where we're going to meet. Everybody should tell me what the x would be equal to. You have to figure out how to solve for x. Okay, that would be one thing that you need to look at. We're going to look at this. You can look at all the chapters, see if you can figure out how to solve for this. But this is how we set up the equation. Okay. We're going to complete this before the final exam. However, I want you to think about this, how to solve for x. So you need to expand x plus 1 squared. There's some part that we haven't quite got to that yet, like solving by factoring. So we need to move on with our chapters in order to get to solve this. But you should be able to set this up till this point so far. All right, we'll get back to this. Now we talked about. Let me take a look at one other example similar to this that we had on our last test, which was set up was a little different, and we could solve it all the way with all the study that we've done so far. So let's move on to that one. Now, if you remember, I asked you this question last time. Let's take a look at it. Here we have when the smaller of two consecutive integers is added to 3 times the larger the result is 43. Find integers. Okay, just remind you that we did not complete the last problem. You should do a little research on it by next meeting to see how to solve that. Okay, for this one, if you remember, this was one of the problems I asked you last time on the test. Those of you who took the first on-campus test, you should find this problem in the last page of your exam. Now, again, remind you that you need to correct all your previous exams. So you got test number 1 already back from me. You need to correct that. I put enough hint for you to complete each problem that you didn't do correctly on the test. If you look at your test carefully, you should be able to correct them in a separate piece of paper and staple it into your exam. Also, I want you to go look at the sample finals and see if you can find any questions or problems similar to those and work that out. And every time we meet virtually online like this, you can ask those questions. All right, now over here we have, again, consecutive integers. So if I assume the first integer is x, all right, what is the next integer? Daisy, what's the next integer would be for anybody? Next integer would be, Daisy says x equal to 1. You mean plus 1, right? Yeah, you mean x plus 1. Very good. So again, we established that if we are consecutively integer, if the first number is x, the number after that would be one more than that, would be x plus 1. And since we're talking about the two consecutive integers here, so that's all we need are these two numbers, x and x plus 1. So we're assuming let the first number be equal to x, and the second number would be x plus 1. Now, they're saying that when the smaller of two consecutive integers is added to, the smaller one is x, obviously, and the larger one would be the one next to it. If the smaller one is added to 3 times the larger one, okay? So, can somebody write this down for me as an equation? Let's see who wants to try that. Roberto, can you write down the equation? The smaller, you have to add them up. You have to add two numbers together. Then would be equal to something like here's 43. Okay, we have one answer here. You're close. Aminita, you said x plus 1 equal to 43. But what happened to this 3 times then? It says when the smaller of two consecutive integer is added, this the smaller one is x, is added to, doesn't say added to the next integer, it says added to 3 times the larger one. So Daisy, you're also missing this 3 times. How are we going to put this 3 times in our equation? Added to 3 times the larger one. Somebody wants to correct that then? The larger one is correct, it's x plus 1, but we're missing 3 times. So how do you do that? Well, no, the larger one is x plus 1. This is a larger number, right? The larger number is x plus, the smaller number is x. Right? This is a smaller number, right? That's a smaller number. We already established this. If the adding the smaller number to 3 times, not power. Now, this would be the larger number. You're getting really close. Renee, you're very close, except you have the extra terms in there. This is a larger number. Okay, if that's a small number, that's a larger number. What's 3 times a larger number? How do you write that? How do you write 3, not x? Renee, you just put 3 times a smaller number. 3 times the larger number. There you go. Daisy got the equation for us. 3 times the larger number. Now, 3 times the larger number would be 3 times the larger number is x plus 1. Okay, so that would be 3 times the larger number. Right? Okay. So in here you have to include the 3. 3 times the larger number. Now this is the equation that we have. Let's compare this with what's given to us. They're saying that when you add the smaller number to 3 times the larger number, so the smaller number is x, the larger number is x plus 1, 3 times the larger number would be 3 times x plus 1 is equal to 43. Can I see a check mark if you can follow this equation? That's how you have to set them up. Okay, now you should all quickly be able to solve for x. All right, let's see who wants to do that. Everybody solve for x and give me your answer. You need to distribute. Okay, see who can go first. Okay, Minion says x equal to 10. Okay, get more. I'm going to keep working with this. I'm going to distribute this and confirm my answer with you. Okay, anybody else wants to give me the answer? Okay, Roberto, what do you think? Okay, another 10 here. So 1x plus 3x equal to 4x. Looks like, well, what you're saying is equal to 10. Okay, keep going. So 4x would be equal to 43 minus 3. So 4x equal to 40. Looks like you're right, 40. And so x would be equal to 40 over, for those of you who took the exam, number 1 on-campus exam, please take a look at this problem here and see what you did wrong on this, because you need to correct. When I say correction, this is what I mean by correction. I want you to write down the problem clearly, write down all your steps, and give me the final answer like this, and come up with one example similar to those. If you can find the closest example I could find in the previous finals so far was the one I was trying to work for you earlier. But let's complete this and we'll talk about that again a little bit more. So if the x would be the smaller integer, then that's what the x is. So you're saying the first number is, so you remember the consecutive integers x and x plus 1. So the first number is 10. So what's the number after that? What are those 2 integers they're looking for? 10 and what? Because it's find the integers, both of them. The integers will be 10 and 11. Very good. 10 plus 1, you mean, right? Yeah, 10 and 11. So those 2 integers that they're looking for are 10 and 11. And you can check your answer quickly. If I multiply the larger number, which is 11, by 3, that becomes 33, and add it to the smaller number, 10, that becomes 43, and that's exactly what they're asking for. Can I see a check mark next to your name if you can follow this, everyone? So just looking at the word problems could be intimidating, but it's not that hard. Once you start setting up step by step, it's not that difficult. Okay, Sashin, you're okay with this? Can I see a check mark next to your name if you are? Okay, so comparing this with what we did earlier, let's go back to this. Here was a little different. It says find two consecutive integers such that the difference of their squares is equal to 19. So the setup is very similar on this one too. We assume the first one is x, the next one is x plus 1, because they want to have a difference of the squares, so we have to figure out the first term square would be x squared, the second term square would be x plus 1 squared, and the equation we set up here was x plus 1 square minus x squared equal to 19. Again, we're going to learn more methods to solve equations like this. We have